Welcome to Lavanya's computer classes. In this video, I will explain linear search and analysis of linear search. What is the worst case, best case and average case of linear search. So what is a linear search? Linear search means searching an element. Linear search is used for searching an element in the given list. So that is called as linear search. For example, if you are taking some elements like this, it is an array representation. So in this we are taking the elements 20, 15, 7, 45, 23. So our next 100. Taking the elements like this. In this I want to search an element. My key element is 23. So I want to search 23 element is in the given list or not. So using linear search you have to searching the element. So how can you search the element? Means this is the array elements. It starts from 0, 1, 2, 3, 4, 5. Totally 6 elements are there. So what is the algorithm for finding element in this? Means if key element. What is key element? Key element is 23. If key equal to a of I, because I value starting from for I equal to 0, I less than n, I plus plus, this is the loop. So if key equal to a of I, then find it is a, then printf, it is a successful search. Otherwise unsuccessful. Like this we can search it. This is the linear search algorithm. Just else printf unsuccessful search. Unsuccessful search. So this is a simple algorithm only. So take the elements, loop elements from I value 0 to I less than n and search each and every element with key. Compare the key element is in the first element or not. So for example, what is here? Loop I value starting from 0. What is n here? N equal to 1, 2, 3, 4, 5, 6. N equal to 0. So I value 0 to I less than 5 means 0 to 5. So what is the key element? Key element is 23. So first key element 23. 23 is equal to a of 0. So what is a of 0? A of 0 means 20. So 23 equal to 20. Is it true or not? Means it is false. So then we go for I plus plus. I plus plus means I value is 0. Now it is incremented to 1. A of 1. A of 1 means is coming to here. So what is a of 1? 50. And what is your key element? Key element is 23. 15 is equal to 23? No, this is also wrong. Then again I plus plus. I plus plus means I value is coming to second place. That is 7. So what is your key value? Key value is 23. What is a of 2? This is here a of 2. A of 2 is 7. 23 is equal to 7? No, here also condition is wrong. Then again we go for I plus plus. I plus plus means I value is now 2. Now it is coming to 3. I3 means coming to here. So what is key element is 23. A of 3. What is A of 3 value? Is 45. 23 is equals to 45? No, it is also wrong. So again go for I value, I plus plus. I plus plus means I value is 4. That means coming to here. So here what is your key value? Key value is 23. A of 4. A of 4 means it is 23. So 23 is equals to 23. Yes. That means it is a successful search. So like this linear search algorithm works. So linear search is also known as sequential search. Sequential search means sequentially one after another each element is compared with its key element. Whenever both are same, then immediately we write successful search. Otherwise check it one after another till the last element. At the end of the element list also we are not getting the key element means it is called as unsuccessful search. This is the concept of linear search. Now I will go for analysis of linear search. Linear search means either we explain any analysis is explained with 3 cases. One is the best case, average case, then last one is worst case. In these three cases, we're just analyzing any algorithm. Best case, average case, and then worst case. What is the best case? Best case means it is search key present at the beginning of the list only. Best. If the search element is available in the beginning of the list, that means first element is your key element. Then within first iteration, the first time only we get the successful search. That is called as best case. Best case means in the beginning of the list only we get the successful search. Worst case. What is the worst case means? Worst case is searching a key at the last index. Last index means last element, that means search key is in the last element or totally not find in the list. Either it is a last index or not find. Unsuccessful search, that is also called as worst case. So what is best case means the element is available in the first index only. That means 0th index, first place only we get that element. Worst case means the element is not at all present in the list, or if it is present, it is the last value, last index position in the given list. Average case. Average case means it is between best case and average case. Between best and worst case. That means it is available anywhere. Either not in the first position or not in the last position. It is available between anywhere in the list. That is called as average case. Video will explain binary search. Binary search with an example. Already in the previous videos I will explain divide and conquer method. So binary search is also an example for one application of divide and conquer method. So first we go for what is binary search. Binary search is a fast searching algorithm with time complexity of O of L log n. So binary search is we have two types of binary search algorithms are there. One is linear search and the second one is binary search. The linear search is also known as sequential search. So linear search is also a good example for searching technique, but in this if the search element is in the last element, if the which element you want to search, that element is in the last position, then number of iterations are more, number of steps are more. Finding that element, for finding one element you have to check all the elements. If the size is more, it takes number of iterations. So that is the one disadvantage of linear search. For overcoming the disadvantage, we go for binary search. What is the binary? Binary means 2. Here all the numbers, the list of elements will be divided into 2 parts. Either we search the elements either in this side or like this, in this part. So that's why number of iterations are almost all half of it will be reduced. That's why binary search is well suited method for searching an algorithm. So it is a fast searching algorithm. Because why it is fast means because either we can search either left hand side or right hand side depend upon the elements. And it is based on divide and conquer method. Binary search algorithm is a good example for divide and conquer strategy. And here we have to remember one point, that is all data items should be in the order. If you want to search any elements using binary search technique, all the items should be in the order. It is very, very important. So these are the some points in binary search algorithm. Now I will explain the algorithm of binary search algorithm. So algorithm BST, binary search BS, while low less than or equal to high. Here we need low element and also high element. I will explain with example. If the low element is always smaller than or equal to high, then calculate mid. How to calculate mid? Means mid equal to low plus high by 2. After calculating mid, then we need search element. We need mid element and search element. First we calculate mid element, that is low plus high by 2. Then search element. Then compare mid element and search element. If both are same, 3 points we require. First point is middle element and search element both are same. That means then we get it is a successful search and the element is found at middle of the position. Then stop your procedure. If it is middle element is greater than search element, that means search element is small compared to middle element, then go to left hand side. That means middle element is here, this is the middle element. Middle element is more means remaining all elements are smaller. So go to right hand side. Our third point is if the middle element is more than search element, then go to, that means middle element is small, search element is more, then go to right hand side. So like this we can check it. Either middle element equal to search element or middle element is greater than search element. That means middle element is more, go to left hand side. If the middle element is small, then go to right hand side. So like this we can start your procedure. Through example I will explain. Here I will take some elements. These are the set of elements. And once again I will tell you, in the binary search all elements should be in the order. So here I will take the elements 3, 7, 9, 10, 12, all are in the ascending order. And then 25, 29 like this. So first I will take the array form. So first find the positions also. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements are there. So these are my 15 elements. So in this first, which element is there? That is known as low, and which element is here? That is called as high. So what is the position of here? Low equal to 1, high equal to, what is our high value? 15. So here low less than or equal to high condition, we have to check it. 1 less than or equal to 15. Yes, condition is true. Once the condition is true, we have to do, what we have to do? We calculate mid element. How can you calculate mid element? Mid element equal to low plus high by 2. So what is our low element? 1. What is our high element? 15. 1 plus 15 by 2. That is 16 by 2. That is called 8. So what is our middle element? Middle element is 8. Okay. Now we go for search element. Which search element is also known as key element. Which element you want to find? That is, for example, we think it is 42. Key element is 42. So search element is 42. What is our middle element? 8th position. So here check it. What is your mid element? A of 8. The 8th position, which element is there? 29. What is your search element? Search element is 42. So first point, either mid equal to search. Is it clear? Is it true? 29 is equals to 42? Wrong. So then compare. Which one is higher? Mid element or search element? So what is our middle element? Middle element is 29. Search element is 42. So 42 is more than your middle element is smaller and search element is more. So search element is more, then go to right hand side. That means here middle element na. So from here we go to right hand side. That means not necessary to check it in the left hand side. That is called as divide and conquer. Depends upon the middle element. Now it is divided into two parts, left hand side and right hand side. So in the right hand side, what is the elements are there now? Again 31, 36, 42, 47, 53, 55, then 62. So this is the elements. Now check the algorithm. If search element is greater than middle element, yes, search element is more than middle element, then what we have to do? Low equal to mid plus 1. So what is our low value actually? Low value is 1. Here starting low value is 1, high value is 15. Now whenever coming to here, low value is middle plus 1. What is our middle? Middle element is 8. So low value is now 9. 9 element is here. So this is now considered as low. This is 9th position. 9, 10, 11, 12, 13, 14, 15. Okay. Now it is low and high is nothing, no change here. So high is still 15 only. Low is 9 and high equal to 15. Again calculate mid. How to calculate mid again? Mid equal to low plus high by 2. What is our low value? 9 plus 15 by 2. 9 plus 15, how much? 15 plus 9. This is 24 by 2. 9 plus 15, 24 by 2. What is 2? That is 12. Okay. So, what is our middle element? 12th position. 12th position means mid element is now 47. But which element you want to search? Search element is 42. Again same thing. Mid equal to search? No. Again compare. Middle element is 47 and then search element is 42. So, which one is more? Middle element is more. If the middle element is more, then the elements is in the left hand side from here only. That means again it is divided into two parts. Here either right hand side or left hand side. So, which side have to go means check it, depends upon the value. The search element is smaller than middle element, go to left hand side. That means again we apply divide and conquer method. So, in this what is the parts again? 31, 36, 42, enough. So, what is the values of here again? It is in the 9th position, 10th position, 11th position. So, whenever middle element is more than search element, then we go to high value, have to change it. High equal to mid minus 1. So, what is high value? Low is nothing, no change. Low is 9 only. High value mid minus 1. So, what is our middle value? 12. 12 minus 1 means it coming to here 11. So, here L is equal to 9 only. Mid is now change it to 11. Okay, Nana? Again we have to do same procedure. Apply divide and conquer method again. Again we calculate mid. Low plus high means 9 plus 11 by 2. 9 plus 11 by 2 means 20, 20 by 2, that is 10. So, what is our 10th? Middle element is 10. Middle element means this one. So, middle element is 36, search element is 42. Both are not same. So, again do it, searching. That means middle element 36 is less than 42. That means middle element is small and search element is more. That means you go to right hand side. Right hand side means here only one element is there. Whenever here search element is smaller than middle element. Middle element is smaller than search element. So, whenever smaller than middle element is smaller than search element, go to right hand side, but check it. L value change it to middle plus 1. So, what is your middle plus 1? Middle value is 10. 10 plus 1, 11. Height we are not changed anything. So, here only. Here only one thing. Left is here and low value is here. High value both are same. So, again calculate mid. Mid is equals to 11 plus 11 by 2. That is 22 by 2. That is 11. So, what is your middle element? The middle element is 11. So, middle element is 11 means what is the 11th position? That is 42. Mid element is 42. What is your search element? Your search element is also 42. So, mid equal to search. So, 42 equal to 42. Then you are getting the element successfully in the 11th position. It is known as successful search. Binary search. See here, out of 15 iterations, 15 values are there. But 1, 2, 3, 4, within 4 searching, 4 iterations only we get that successful search. This is the main advantage of binary search. Binary explain selection sort. What is the selection sort? What is the algorithm and how to implement selection sort with numerical example? I will explain in this video. This is Unit 5 PPS programming for problem solving. In this programming for problem solving according to JNTUH R18 and also R22 Unit 5. Algorithm for selection sorting and numerical example. First I will explain with the numerical example. This is the some set of elements, list of elements 13, 22, 51, 15, 3 and 21. Now question is coming like this. Consider the list of elements 13, 22, 51, 15, 3 and 21. Arranging all these elements in the order using selection sort algorithm. So method in the name only, it is a selection sort. Sort, what is the meaning of sort? Sorting means arranging all the elements in a proper order. Arranging all the elements in a proper order is called as sorting. How can you sort? Means using so many sorting techniques are there. Either go for selection sort, merge sort, quick sort and insertion sort. But in your syllabus you have selection sort, insertion sort and merge sort is there. I think 3 sorts are there. Bubble sort, bubble, selection and insertion sort is there. Now I will explain selection sort. So first we take all the list of the elements, keep it in the order, array elements. Array elements means, for example, we take this, everything is in name of the array name is A. So this is the indexing. This is the A of 0. This is A of 1. Array elements is always starts with 0th location. A of 2. This is A of 3, A of 4 and A of 5. So totally 6 elements are there. So that is from 0 to 5. Now in this selection sort, first step is, first we take to accept the first element. Find first element and minimum element. This is the step 1. The step 1, first find out which one is the first element and which one is the minimum element. So which one is the first element? First element is always in the 0th position, index, 0th index. So A of 0. So what is the A of 0 element? The A of 0th element is 13. So 13 is the first element, and which one is the minimum element? So find out in these all these elements which one is the minimum element. The minimum element is 3. 3 is in the which position? Means this is in the A of 4 position. So this is the minimum element. So first element is 13. Second element is minimum element is 3. Then compare first element and minimum element. Compare first element and minimum element. What is our compare first element? First element is the 13 and minimum element is the 3. So that first element is always, because we wants to arranging all the elements in the order, means sorted order. Sorted order means ascending order. Smallest element is always in the first position. So A of 0 and compare which one is the minimum element? A of 4. So A of 0th element is 13, A of 4 element is 3. So 13 is greater than 3. That means first element is more than last element. So whenever first element is more than smallest element, we just swap it. Exchange the elements 13 and 3. That means 13 is changed to 3 and 3 is changed to 13. Positions will be changed. So in the step 2, how it will be changed means, again this is the array location. 0th position, first position, second position, third, fourth and fifth. This is A of 0, A of 1, A of 2, A of 3, A of 4 and A of 5. So now changing 0th position and 4th position. That means 3 is coming here, then 22 in the same position, 51, there is no change in these values, and 13 is coming to here, and then 21. So whenever first element and minimum element change, automatically the smallest element is coming into the first place. So whenever is swapping the element, then it is divided into 2 parts. This is called a sorted order, and these all are the unsorted. That means these elements are not in the order. Okay. So whenever the first iteration step 1 is completed, one element is in the sorted manner. Now in the step 2, take only unsorted elements only. 3 keep it in the proper place because the element is already in the order place. So take only step 2. Step 2 means again we take these elements. What are the elements are here? 22, 51, 15, 13, 21. Only these elements are not in the order. So take these elements only. 3 is already in the order. Okay. So this is the sorted order. Don't do anything from this. Okay. Again we are divided into this one. This is again A of 0th position. This is A of 0. This is in A of 1. This is A of 2, A of 3, A of 4. Again same procedure. We repeat the same procedure. How we are repeating the same procedure means again find out again first element and again minimum element, same rule. What is the first element? A of 0. The A of 0 element value is 22. Minimum element. Which one is the minimum element out of these 5? 13 is the minimum element. In which position means? A of 3. Again compare. Compare which element you have to compare means compare first element and minimum element. First element is always smaller than to next elements because it is in the order. So, A of 0 and compare A of 3. A of 0 is 22, A of 3 is 13. 22 is greater than 13. Whenever A of 0 value is more than A of 3 minimum value, just swap it. Swap which elements means A of 0 position and A of 3 position. So, after swapping, then one step 3 or otherwise in this only 3 is in order, 22 is coming to here, 13 is swapped to here. So, 13, 51 is no change here, 51, 15, 22, 21. So, whenever first element is swapped, now this is divided into two parts. These two are in the sorted order. These two are the sorted and these four are called as they are in the unsorted manner. Is it clear? Now, after step 2 is completed, two elements are in sorted position, remaining all are unsorted. Then step 3, same thing. In the step 3, take these unsorted elements only, 51, 15, 22, 21. In this again take it, same procedure, first element is the 51, minimum element. Which one is the minimum element? 21. Then compare first element and min element. First element is more than min element, so swap it. Swap. Whenever we swap it, the elements are coming like this. 21, 15, 22, here swap minimum element is 15, sorry. Minimum element is 15, so swap these two elements. That means 15, 51, 22, 21. So, after step 3 is completed, the sorted elements are, sorted like this. Which elements are sorted means 3, 13, 15. These are in the sorted manner. Already these elements are in sorted. And then 51, 22, 21. These are not in the order. So, take these values. These are the unsorted elements. These are the unsorted. Okay. 3 steps are completed means 3 elements are already in the order. Then step 4. Step 4 we take these elements only 51, 22, 21. Again considered as it is an array. In this it is the first element. Again same steps. First element is 51. What is the minimum element? Minimum element is 21. So, again compare 51, first element is more than 21. Whenever first element is more than minimum element, just swap it. Swap means swap A of 0, comma A of 3. It is 0th position, that means swap these two elements. So, after step 4, 21, 22, 51. So, already 3, 13, 15 is in the sorted manner. So, these are the sorted, these elements in the sorted and these elements in the unsorted elements. Already these elements already in the order, but you have to again change it. This is the first element. First element is 22 and first element is 22 and minimum element is also 22. Whenever the first element and minimum element both are same, there is no swap. There is no swap. So, this is step 4, this is now step 5. Step 5 means 3, 13, 15, 21, 22, 51. So, after step 5, these elements are coming like this. These everything is in the order. Sorting order means all elements are arranged in the ascending to descending. 3, 13, 51, 21, 22, 51. All elements are sorted. See here how many elements are there? 1, 2, 3, 4, 5, 6. n is equal to 6 means number of iterations n minus 1. Within n minus 1, the elements, all elements are coming into the sorted order. N minus 1 means 6 minus 1, that means 5. Within 5 steps, all elements are in the order. So this is the technique of selection sort algorithm. Selection sort, we have to select. Which elements you have to select means first element and minimum element. Select first element and minimum element. Compare first element and minimum element. If the first element is more than minimum element, swap these two. Otherwise, not necessary. So, same procedure, same thing we repeated until all the elements are in the order. So, this is the numerical example for selection sort. Now, I will explain how to write an algorithm. Algorithm for selection sort. This is the algorithm. What is an algorithm means everything is explained in terms of general English language is called as a algorithm. Step 1. What is the step 1? Starting from the first element. We search the smallest element in the array. That means first we have to select the first element and also smallest element in the array and replace it with the element in the first position, and immediately we can replace it. When we replace it, if the first element is more than smallest element, then we move on to the second position and look for smallest element present in the sub array starting from index 1 till the last index, because 0th position element is already in the order. So, start from index 1. Step 3 is we replace the element at the second position in the original array, or we can stay at the first position in the sub array and second smallest element. Step 4 is this is repeated until the array is completely sorted. So, this is the algorithm for selection sort algorithm. Thank you for watching my video. If you like this video, please subscribe my channel. Thank you. Video will explain bubble sort algorithm. First, before going bubble sort algorithm, first we find out what is the sorting. Sorting means it is used for arranging all the elements in a proper order, ascending to descending or descending to ascending order. So, now we will explain bubble sort algorithm with a numerical example. So, first we will take one array, list of elements. The list of elements are 5, 1, 4, 2, 8. So, all the elements are stored in the form of an array. Now, how the bubble sort working means, bubble sort how many elements are there? 1, 2, 3, 4, 5 elements are there, means within n elements, that means number of elements are n, 1, 2, 3, 4, 5. 4, 5 means 4 passes. Within 4 passes, the elements are coming into the particular order. So, first how it is working means bubble sort starts with very first 2 elements, comparing them to check which one is greater. So, in the bubble sort algorithm, take first 2 elements and comparing with each other. The first element is always smaller than the second element. If it is not there means just swap it. So, this is the pass 1. So, there are 5 elements are there means within 4 passes the elements are must be in the order. So, first we take the elements 5, 1, 4, 2, 8. First compare first 2 elements 5 and 1. The first element 5 is greater than second element. So, if 5 is greater than 1, so just swap it. Swap it means 5 element and first element both are interchanged. So, 1 is coming first, then 5, then 4, then 2, then 8. Then leave the first element here, then go to this element. This is the pass 1, this is the step 1. In the step 1, first element is changed. Then in the second step, compare second 2 elements, these 2 elements 5 and 4. Again, first element 5 is greater than 4, again swap it because 5 greater than 4. So, again elements are changed 4 and 5. Then third one, the third step just compare 5 and 2. Again 5 element is more than 2, then again swap these 2. So, swap since 5 greater than 2. Then again compare 5 and 8. Here first element is smaller than the second element. So, there is no swapping because already these numbers in the order. So, after going 4 steps 1, 4, 2, 5, 8. Pass 1 is completed. So, in the pass 1, 1, 2, 3, 4, 5 elements are there now. So, within 4 steps the last element is coming to the which one is the greater element, that element is coming into the last place. So, first pass 1, once pass 1 is completed, the larger element is coming into the last position. Okay, then we go to pass to. This is the pass to. In the pass to, already last element is going into the last place, so not necessary to change anything. The remaining elements 1, 4, 2, 5, 8. It is bubble it. Bubble it means the element is already in the order. Then again step 1. Step 1 means comparing these two elements 1 and 4. First element 1 is smaller than 4, so there is no swap. There is no swap means same thing 1, 4, 2, 5, 8 is already bubbled one. Next, second step. Second step means we have to compare these two values 4 and 2. In the 4 and 2, first element is greater than second element, so we have to swap it. Swap 4, 2. That means 1, 2, 4, 5, 8. Next step, third step. Compare these two elements 4 and 5. It is already bubbled one because it is already in the swapping position. It is already last one 4 and 5. So 4 smaller than 5. First element is smaller than 5. Also no swap. So no swap means 1, 2, 4, 5, 8. So it is already bubbled one. After swapping all the elements, this is also in the order. So these two are the bubbled. So pass to 1, 2, 3, 4 elements are there. Within 4 elements, within 3 steps, all the elements are order. Okay. Next one is pass 3. Pass 3. In the pass 3, we just take 1, 2, 4 because 5 and 8 elements are already in the bubbled position. So these are already in the order. Now again pass to 3 means 1, 2, 3 are there. Within 2 steps only have to change it because first one already the elements are in the order, but have to check everything proper order. Compare these two elements 1 and 2. 1 is smaller than 2, so no swap. So no swap means same thing 1, 2, 4. Already 5 and 8 are in the bubbled places. That means those are already in the proper order. So not necessary to change anything. Then again next step. Step 2. Compare these two. That means 2 is smaller than 4. It is already in the order. So no swap. That means 1, 2, 4, 5, 8. These already in the bubbled ones. So 3 elements are there. Pass 3. Within 2 steps, all the elements are in the order. So whenever we coming to here, this is also bubbled one. Next, pass 4. Because 1, 2, 3, 4, 5 elements means have to write all pass 4. 4 elements we require, n minus 1. Already the elements are in the order, then also you have to check it. So 1, 2, 4, 5, 8. These all elements is already in the ordered place only, so bubbled one. So in the how many elements are there means only 2 elements are there. 2 elements are there means within first element only have to write it. Within one element the elements are order 1 and 2. So one element is smaller than 2. So there is no swap. So within the one place 1, 2, 4, 5, 8. All the elements are in the order. Everyone is the bubbled ones. So this is like this. We can sorting the elements in bubble sort. Okay. So this is the bubble sort algorithm. Numerical example. So what is how you write it the algorithm? First we have to check it any element. First element compare with second element. So bubble sort is the simplest algorithm. So bubble sort is also known as exchange sort. Bubble sort is the simplest sorting algorithm. In this algorithm, the array is traveled from 0 to n minus 1 of the array and compare one element to another element and swap these values in between if the next element is less than the previous element. In other words, bubble sorting algorithm compare two values and put the largest value at the largest index. Okay. So this is the sorting of this is the bubble sort algorithm. So read all these algorithm. Already I posted the algorithms for selection sort. Now it is bubble sort. After that I will explain insertion sort. In this video I will explain insertion sort algorithm. So insertion sort algorithm, it is advantage of insertion sort algorithm is it is very simple for implementation and it is efficient for small data sets. It is very simple method also. So what is the algorithm means? Here there are some steps are there. Step 1 is, if the element is the first element, assume that it is already sorted and return 1, because sorting algorithm means all the elements are arranged in the order. For that we have to take some set of elements and start comparison. In this, first we take the first element. So first element, it is not necessary to compare any other elements, so we thought it is in the ordered position. So step 2 is, pick the next element. Take the second element and store it in separately in a key. Take the second element, already first element is in the order manner. Take the second element and consider that is a key element. And then step 3 is, now compare the key with all elements in the sorted array. Sorted array. In the sorted array already first element is there. So compare the key element and sorted element. Step 4, if the element in the sorted array is smaller than the current element, then move to the next element. If the sorted array element compared to this one is a smaller one, then keep it, go to next element. Otherwise, shift greater element in the array towards right. Then otherwise it shifted to move to next one. Step 5 is, insert the value. Inserting where in the proper position. Then repeat until the array is sorted. Same steps you have to repeat it until all the elements are in the ordered manner. Now I will explain with an example. For this I will take some array elements with 1, 2, 3, 4, 5, 6 elements. 12, 31, 25, 8, 32 and 17. So these are the elements. Now I will go for first step. Initially we have to compare first two elements. Because it is already, first take the first element, that is 12. 12 we think it is already in the sorted manner. Then go to next element, 31. It is considered as it is a key element. Then step 1 is, compare these two elements, 12 and 31. Here 31 is greater than 12. So that means both the elements are already in the ascending order. So now it is 12 is thinking that it is already in the ordered manner. So we take 12, 31, 25, 8, 32, 17. Then we consider 12 is already, compare these two elements. Already both are in the ordered manner. So 12 is considered as it is a sorted array. So 12 is already in the position. This is the sorted one. Next move to the next two elements. Move to the next two elements and compare with. So what are the next two elements? 31 and 25. 31 and 25. If you are comparing this 31 and 25, 31 here, 25 is smaller than 31. So 31 is not in the correct position. Order is changed. So now swap 31 and 25, because you have to change the positions of all these two one. Along with swapping, insertion sort will also check it with all elements in the sorted array. Already how many elements are there in the sorted array? Only one element is there. So not only shifting these two, compare with other elements also. So after shifting, the elements are like this. 12 is already in the sorted array. Then these two elements are swapped, 25 and 31. Then 8, 32, 17. These are anyway, it is not at all changed. Okay, so this is the array. Now we consider as these two are in the sorted, because 12 and 25 are already changed, already in the same position, so no problem. 12 and 35 are in the sorted order, these elements. Now we compare next two elements. These 12 and 25 already in the sorted elements, so change it to these two elements, move to these two elements, 31 and 8. In this 31 and 8 not in the sorted order, because first element is greater than next element. So here 8 is smaller than 31. So just swap it, 31 comma 8. And then not only swiping, here we one more thing is also there. That means first 12, 25 it is already in the sorted manner. Then 8, 31, these two are swapped, and 32 and 17. There is no change in these values. Is it clear? Next, once we are coming to this one, After swapping it, here checking with the sorted array also. If you are comparing these two, again 25 and 8 is also not in correct positions, because before position all the left hand side elements are compulsory smaller than the current key element. So these two are not in the odd position. So swap these two. Which elements have to swap means swap 8 comma 25. If you are swapping, what is the elements or how the elements are means again 12, 8, 25, 31, 32 and then 17. Again we go for this one also. Again we compare these two elements, because these two elements is also not in the correct position. Again swap these two. Swap means again 8, 12, 25, 31, 32, 17. After that these all elements are in the sorted order. These anyway are not touched till now. So these elements are in the order now. Take the elements and again new paper. What is that elements? 8, 12, 25, 31, 32, 17. So after shifting all the elements, those in the order. Now we compare to, that means these three elements are already in the sorted order. Move to the next two elements, that is 31 and 32. So these two elements are in the already in the sorted order, so not necessary to compare anything. So up to this, these elements are in the sorted till now. Okay, these elements are sorted. There is not necessary to change anything. Then we take these two elements, 32 and 7. Here 32, 7 means 32 is more than 17. So have to swap it. After swapping, the elements are 8, 12, 25, 31. These two elements are swapped, 17 and then 32. After that again what you have to do means, take whenever the element is changed, compare with the left elements. Compare these two elements. Compare these two elements means these two also not in the order, because 31 is greater than 17. So swap these two elements also. So how can you swap it means again 8, 12, 25, then these two are swapped, 17, 31, then 32. Okay. Then again this change now compared with previous elements, these two elements. If we are changing these two elements, 25 is greater than 17, again we have to swap it. If you are swapping 8, 12, 17 is coming in this place, then 25, then 31 and 32 are in the positions. Okay. Now compare these two elements. If we are comparing these two elements, these two are in the proper place, because 12 is smaller than 17, so no swap. Okay. After that again compare these two elements also are in the order. So after comparing all these elements, now all the elements are in the order. So this is called as insertion sort. Insertion sort means just comparing with your previous values and all the elements are in the proper order or not, check it. So these all are the algorithms: insertion sort, selection sort, bubble sort. Read well all these algorithms. So this is the algorithm. Thank you for watching my video. If you like this video, please subscribe my channel. Thank you.